Hi, this is Sikandar Rafiq and you are watching the DevCore Learn Software Development YouTube channel. So in the last video we had discussed the database architecture and three-tier architecture. So the next most important question is, and you might be thinking about how database ensure that the operations like money transfer should be correct and reliable. So if you might be thinking about it, so this video is for you. So today's topic is transactions and asset properties. So by using the transactions and asset properties, database makes sure that the operations like money transfer and reservation systems remain correct and reliable. Okay, let's deep dive into the today's topic. Learning objective: by the end of this topic, students should understand what is the database transaction and why transactions are very important, what are the asset stands for and asset properties. So four asset properties are atomicity, consistency, isolation, durability. We will discuss all these four topics and then real world examples of transactions, how Postgres implements the transactions. Okay. Okay, let's see the real world problem. For example, you want to transfer the amount from one account A to account B. So account A has $5,000 and account B has $3,000. So the total funds are $8,000. So it has two steps, you can see. So one step is deducting the amount from $1,000 from the account A, so it remains the $4,000, right? So if this step is successful, and then the step 2 is adding the $1,000 from the account B. So if there is a system crash due to any reason, so then account A has $4,000 and account B has the same $3,000. So total funds is $7,000. So $1,000 is disappeared. So this is the cash loss problem. So this is the real world problem. So Atomicity fixed this problem. So we will discuss in the next how we will fix this problem. What is a transaction? Transaction is the ordered sequence of one or more database operations that are executed as a single logical unit of work. And the simple statement is transaction is a group of database operations that either all succeeded or all failed. So in the previous example, you see we have the two operations. One is deducting from account A and the second one is adding in the account B. So all these two transaction make sure all these two steps, maybe two or more. So in this example we have the two steps, right? So all the steps are done successfully or nothing. So total funds remains $8,000. If there is some issue, then this deducting from the account A is also rolled back. So this is what transaction makes sure. Here is the real life analogy. For example, you go to the store and scan the items, total calculated, So you use the credit card, and there are two possibilities now. One possibility is transaction is succeeded. If payment succeeded, then you get the slip, and then the inventory is updated. So the second possibility is payment failed. So you don't get the receipt and inventory is not updated. No sale completed, right? So these are all the three steps. One is total calculated, second one is payment made, and the third step is sale updated. So if there is some problem, then whole the application is rollbacked. So payment not successful and sale not updated. So this is the real life analogy. If payment succeeded, then you get the payment is made and you get sale is completed. Okay, why we need the transactions? So in the previous examples, you have seen we have some problems. Partial update may occur. Data may be inconsistent. So in the previous example, you have seen data is inconsistent. It should be total fund should be $8,000, but due to some problem, it is the total funds is now $7,000. So this is the inconsistent data. Money may be lost. So in the same example, you have seen $1,000 is lost. So I have the same problem few days back in my Askari bank account mobile app. For example, in the my Askari mobile app, I want to charge my MTech account. So payment is made and amount is deducted from my account. Amount deducted. So this is the step 1, and the step 2 is it should be added to my MTag account. So there is a problem and this step is not carried out. So money lost. So this amount is lost. So this shows that there is some problem in the software or database, and they are not using the transactions. So due to this, money is lost. Although I have to call the bank and 1 or 2 times and then money recovered, but there is some problem which shows the software is not properly using the transactions. So due to that, this problem occurred, right? So this is the money loss problem. Okay, inventory may be inconsistent. So you could see the sailing tickets or reservation, the airline tickets, etc. So if it is not properly synchronized, then you will get the wrong inventory. Application may produce the incorrect results. So these are the problems. If we don't use the transactions, we will see all these problems in the software. Okay, here is the transaction life cycle. So you have seen the item is scanned, total is calculated, then the second stage is SQL executed. So if all goes fine, then we need to commit this statement. So in this case, then all the application, all the transactions will be saved in the database. If there is some problem, so we will use the rollback command. So all the transaction will be rolled back. So no transaction is happened. No item statement, SQL statement is executed. It is just like that, right? So okay, we will discuss the post-case example. So here you can see begin command, update account 1. We are deducting the $1,000 from account 1 where ID is 1, and then the second SQL command is we are updating the account 2, adding the balance in the account 2. So if both these statements are executed and work fine, then we will commit this statement. So then this stage, and account 1 is properly updated and account 2 is properly updated. So if there is some problem due to any reason, then we will use the rollback command. So all the SQL statements are rolled back. So it is just like the no SQL statement are executed. So this is the post-case SQL example. Okay, what are the 4 asset properties? Atomicity, consistency, isolation, and durability. First one is atomicity. Atomicity means a transaction is treated as a single individual unit. All operations are succeeded or none of them succeed. So bank balance transfer example, same example you can see. If both statements are executed, then we will commit the statement, otherwise we will roll back. So this is the balance transfer example. So post case example already we have seen. Consistency. Transaction must take the database from a one valid state to the another valid state. So the same bank example, yeah, we have seen here. So it should not be, funds should not be inconsistent. Here you can see it is the inconsistent. So transaction make sure if both the operations are succeeded or both are rolled back. So total funds remain the same, $8,000, right? So this is the consistency. Database should be in a valid state. Okay, isolation. Here you can see the two transactions are carried out in the same time. So it will read the first transaction A, user A read the balance, it is $1,000, and the same user B read the balance, it is the $1,000. Okay, it will draw the 200, first one draw $200 and second one, and write the balance to $800. So at the same time, user 2 in the transaction B will draw $300 and write the new balance $700. So this is incorrect because the correct balance is $500 because the user A will draw $200 and user 2 will draw $300. So it should be $500 rather than $700. So this is the typical concurrency problem, last right phase. So in the isolation we have discussed in the previous videos. So database make sure and it will lock the row to avoid these type of problems. So how PostgreSQL ensure the isolation level? PostgreSQL use the multi-version control system, and row level locking and isolation levels. So all these three things we have discussed in the previous video. So if you have not watched the previous videos, please watch them before going forward. Multi-version concurrency control, right? Okay, the last one, fourth one, is the durability. Durability means once transaction is committed, its changes are permanently stored even if the system crashes or immediately afterward. So if commit statement is executed, here you can see if the commit statement is executed, so these both SQL statement transactions are permanently stored in the database, and after that, if the executing the commit statement, if system crash, so after the recovery we will see these transactions, we will not lost these transactions. So this is called the durability, right? How the Postgres achieve durability? So it will use the write head logging, checkpoints, and crash recovery. Okay, the summary of the asset. Atomicity, all or none, meaning an example is the money transfer, as we have seen. Consistency means valid states remain valid. It will not turn into an invalid state. Total balance unchanged, as we have seen in the previous videos, previous slides. Okay, isolation, transaction does not interfere, prevent lost update. So this is the example of lost update. So this write is lost, right? So by using the isolation levels, Postgres makes sure this problem does not occur. And the durability. Committed data survives crashes. So after the crash, if data is committed, so you will see the same data. You will not lose the data. So wall recovery is the example. Real world example. Okay, banking, money transfer, and ATM cash withdrawal, and airline booking, seat reservations, and e-commerce, order placement, so hospital patient record updates. So in all these workflows, you need to database make sure by using the transactions and isolation levels and other techniques to make sure these data remains valid by using the transaction and asset properties we have discussed. Okay, PostgreSQL command. So by using the begin command, where transaction is started, so this command start the transaction, start of transaction. Okay, then execute SQL statements. So multiple statements we can execute here. So if all succeeded, then we use the commit. If there is some problem, so database use the rollback command. So nothing is done. Nothing done. It is just like the same, we have not executed all these statements, right? So if it contains the multiple statements from 1 to n, so if all succeeded, then we commit the database transaction, all the database, otherwise we will roll back all these things. So this is the same thing we have depicted here. If all statements executed perfectly fine, then commit and save the changes permanently to the database, and database is updated. So if there is some problem, then undo changes by using the rollback command and initial database state, just like this one, just like the database is at this stage, at the start of the transaction, by the start of begin command, right? Okay, for example, the insert statement, I will for example data okay, and then insert students name and values Ahmed. So this is the, for example, our first statement, and the second statement is update departments set total student. For example, we will update the total students is equal to total students plus 1. Plus 1. So if all statements, both statements are, this is the second statement, and then we will commit the database, commit the transactions, right? So this is the example. Okay, so this is the another example of transaction. Okay, common misconception, each SQL statement is automatically part of the larger transaction. No. So as we have seen, so there are two SQL commands. One is inserting the data into the table, students table, and then updating the department's total student. So we need to make the transaction to both statements succeeded or failure, right? So by using the transaction. Okay, in Postgres, every individual SQL statement runs in its own transaction by default, auto commit mode. When you need multiple transactions to succeed or fail together, you explicitly start a transaction with the begin command and finish it with the commit or rollback. So just like this. So this is the start of the transaction and this is the end of the transaction, right? So key takeaways. Okay, transaction is a group of operations treated as a one unit of work, as we have seen in the couple of examples today. Transaction prevent partial updates and inconsistent data and money lost. Asset ensure reliable transaction processing. So Postgres provide the full asset compliance using the transactions, multi-version concurrency control, write-ahead logging, and cache recovery and isolation levels. So this concludes the our topic. Thank you so much for watching the video. Please like, share and subscribe. So the next video we will install the Postgres and pgadmin 4 and create the database and the table. So alongside we will use the database, Postgres database as well. Thank you so much for watching the video. Bye bye.